Last time we learned about sampling error and how to measure sampling error. And we ended on a concept that I said, make sure that you understand this concept because it's going to build from that. So I want to spend a couple of minutes talking about the sampling distribution of differences before we get too deep into this topic, which is confidence intervals. Let me just say one thing about confidence intervals, and then we'll do a little bit of a review. So confidence intervals are a way that we have of trying to figure out why two or more sample means are different from each other. So let's just pretend that we've got an experiment. Let's see, where we're testing the brightness of your screen and reading speed. All right, so we have a low lit screen, a medium lit screen, and a high, bright screen. So we've got these three different groups, which means that we're going to have an average reading speed for each group, right? So we're going to have three means. Each of those means is considered as, a sample mean. So you have a sample mean from the low, medium, and high brightness screens. Now, those three means are going to be different no matter what. If you've got a different group of people in each of those conditions, well, there's just going to be natural variation between them. So the question becomes, why are these three groups different from each other? Why are their means different? Is it just because of sampling error alone? Because we expect sampling error no matter what, right? So maybe it's just sampling error. But maybe there's something on top of that. Maybe there's other stuff going on. Maybe there really is an effect of screen brightness. And so confidence intervals, you'll learn, give us another way that we can look at the three means and make some decisions about what is the likelihood that all we're looking at is sampling error versus there's sampling error plus something else going on. So I want to take now just a minute to go back, if my screen will let me here, go back to where we left off last time. And last time we learned that you could, actually I'll go back another one more. May as well, go for the full effect here. Okay, so we've looked at sampling distribution of differences. And we learned that it is a distribution, of differences, right? Differences of what? Between two sample means, x bar 1 and x bar 2. And x bar 1 came from population 1, x bar 2 came from population 2. And we made the assumption that these two populations were identical. Okay, and it's only an assumption. But we have to start off, innocent until proven guilty. So we're going to start off assuming that these two populations are identical. So x bar 1 comes from population 1, x bar 2 comes from population 2. And we said even if it's true that these populations are the same, well, we're going to still expect to see differences between x bar 1 and x bar 2. Why is that? Because there's sampling error. When you sample, you're only getting an estimate. You don't have all the data at your disposal. So x bar 1 is just an estimate of mu1. X bar 2 is an estimate of mu2. So even if these are the same, you wouldn't expect x bar 1 and x bar 2 to be the same. So what we want to do is we want to exhaustively sample from each population so that we get all possible differences between x bar 1 and x bar 2 when mu1 and mu2 are equal. Okay, so we're going to see what are some differences that we might get between them. And of course, we can plot those, and that's what we did here. We plotted the differences. Now this is hypothetical, so hypothetically it extends from negative infinity to positive infinity. But basically, it's saying that you can get a difference any size between x bar 1 and x bar 2, and it still could belong to this distribution. And this distribution, the sampling distribution of differences, is just showing us what size differences we can expect to see just because of sampling error alone. So that's important. This is a distribution of sampling error. It's saying that when there's sampling error, you can get a difference this big, you can get a difference this big, etc. All right. Of course, though, if you get a difference between your two sample means that's in one of the two tails, well then, although it could technically belong to this distribution of sampling error, so it could still just be sampling error, chances are it's not just due to sampling error. There's something else going on, okay? And so, again, you need to look at how large a difference there is between your two sample means, but that's not the full story. Nor will you learn the full story until we get to chapter 7. Okay, but a big part of the story is how big is the difference between your means, because the bigger the difference, the more likely they are to be out in the tails. And if they're out in the tails, you're going to say, oh, well, that could be sampling error, but it's probably not. So we are going to assume that our initial assumption is false. Assume that our assumption. We are going to say that our initial assumption is false, and maybe mu1 does not equal mu2, all right? And that is where we left off. Let me just get to the end of this slide. Actually, this is where we left off, but it's the same thing, all right? So if you get a small difference between your sample means, it's more likely to be in the middle of this sampling distribution of differences, the mean of which is 0. Remember that these are all negative differences between the means. These are positive differences between the means. And because mu is the center of gravity, the negative differences cancel out the positive differences, and we're left with 0. So if you get a small difference between the means, you're close to that 0 mark. These are very high probability events when there's just sampling error, so we're not going to, bat an eye here. We're just going to chalk this up to sampling error. But anything out in the tails, although technically it could belong to this distribution, it probably doesn't. And we are going to say that maybe our initial assumption here was false. Okay, that is where we left off. So confidence intervals just gives us another way that we can try and get a sense of whether or not means are different because of sampling error alone or something in addition to that. And that's where it gets really exciting, because if it's something in addition to that, going back to our brightness of screen, our screen brightness example, if there's something in addition to sampling error, then we're going to want to argue that it was the brightness of the screen that made those means different.